An experiment was carried out to determine the relative molecular mass, MR, of a volatile hydrocarbon X that is a liquid at room temperature. A known mass of X was vaporised, that means turned into a gas, at a temperature and pressure that we know, and the volume was measured in a gas syringe. All our data is shown in this table, so it shows us what mass of X we used, what temperature we were at, what pressure that gas exerted, and what volume in the gas syringe it took up. Now we've been given a lot of data there. We've been given a T, a P, a V and a mass. And we've been given a gas constant R here in the question. So it's clearly indicating to me that I need to be using the ideal gas equation, PV equals nRT. I've been given a P, a V, a T and an R. So I'm going to be rearranging this to find N. So N is PV over RT. So that's our first step. Now we need to remember the units for the ideal gas equation. Our pressure needs to be in pascals. So this is not in pascals, so we need to convert it. So this would be times 10 to the 3 to get it into pascals. Our volume needs to be in meters cubed for a gas. So from centimeters cubed to meters cubed times 10 to the minus 6. Our temperature needs to be in Kelvin, which it already is. So we're going to put those numbers in. So 102 times 10 to the 3 times 72 times 10 to the minus 6 divided by the gas constant R, 8.31, times by the temperature that we've been given, 373 Kelvin. We're going to put all that onto our calculator. So it's a good idea to use that fraction button on your calculator to keep it looking like it does on the page. Also, this will help with the rules of BIDMAS and not falling foul of doing a mistake in your multiplying or dividing. So my calculator has given me 2.37 times 10 to the minus 3 moles. Okay. Or 0.002737 if you want it like that. So we've managed to get moles, but the question is to find the MR. And MR, if you remember that mass is Mr. Moles, then MR is mass over moles. And we've been given the mass, but it's in the wrong unit again. We need it in grams, so we need to divide by 1,000 times 10 to the minus 3. So 194 times 10 to the minus 3 divided by our moles, and we're going to type that on our calculator, or if we've kept the number on our calculator, we can use that fraction button again, type in the top line and just press divide by answer. And we're getting an answer of 81.88. Now I'm just going to check, it does say appropriate number of significant figures. So if we have a look, we've got 3 significant figures, 3 significant figures, 3 significant figures, but only 2 significant figures for the volume. So that means we would need to give our answer to 2 significant figures. So we're going to give our relative molecular mass as 82. The question then continues on the next page. It asks us to analyse a different hydrocarbon Y. That is, it's a hydrocarbon and it's made of 83.7% biomass carbon. So let's just think about that. If it's a hydrocarbon, it's only made of carbon and hydrogen. If it's 83.7% biomass carbon, then we can find by subtracting from 100 that the rest of it, 16.3%, must be hydrogen. These are our percentages by mass. If we divide them, if we convert mass to mole, we divide them by their ARs, then we will get the moles of each of these. So on our calculator, get 6.975, and then we had 16.3. So we divide them by the AR to convert them to moles, and then we want to find the simplest ratio. So we divide them by the smallest. So we're dividing both by 6.975. And then we're getting 1 to 2.33. But empirical formula is the simplest whole number ratio. Now what you have to do here is spot that 2.33 is 2 1/3. So we're going to multiply by 3 to get 3 and 7. So our empirical formula is C3H7. And then we're going to go back and find out what our MR is. So our empirical formula mass is add up C3H7. So 3 12s and 7 1s. That's 43. If we work out how many 43s fit into 86, we find out that it's 2. So we need to double all the numbers. And we'll get 6 to 14. And that's the end of our question.